This lesson is to solve systems of equations in two variables in which one. Recall that a system of linear equations is a set of two or more linear equations. A solution of a system is an ordered pair that satisfies each equation in the system. It's the point where they meet. The point where the graphs of the equations intersect represent solutions of the system. A nonlinear system of equations is a system in which at least one of the equations is nonlinear, so not a straight line. For example, a system that contains one quadratic equation, so the parabola, and one linear equation, a straight line, is a nonlinear system. A system made up of a linear equation and a quadratic equation can have no solution, they don't touch, one solution, they touch at one point, or two solutions, as shown below. Remember, a quadratic function has the form y equals ax squared plus bx plus c. To graph a quadratic function, you start by using axis of symmetry equation, x equals -1 times b divided by 2a, to find the axis of symmetry, and then plug that value back in and find the vertex. Solve the system by graphing, check your answer. So you're going to graph y equals x squared plus 4x plus 3, and you're going to graph the axis of symmetry, which is x equals -2, the vertex -2, -1, the y-intercept is 3, and then they pick another point, -1, 0, or you could have just reflected the 3, the y-intercept, across. Graph y equals x plus 3, the slope is 1, the y-intercept is 3, and then find the points where the two graphs intersect. The solutions appear to be at -3, 0, and 0, 3. To check, you're going to substitute -3, 0 into the system, 0 for y, -3 for x for the quadratic equation, and 0 for y, -3 for x in the linear equation. And we get 0 equals 0 and 0 equals 0. So we know that is a solution of the system. Then we're going to substitute 0, 3 into the system, 3 for y and 0 for x in the quadratic equation, and 3 for y and 0 for x in the linear equation. And we get 3 equals 3 and 3 equals 3, so we know that's also another solution to the system. Solve the system by graphing, check your answer. Y equals x squared minus 4x plus 5, and y equals x plus 1. This one's for you to try on your own, and then you can check back for your answer. So we're going to graph y equals x squared minus 4x plus 5. The axis of symmetry was x equals 2, the vertex 2, 1, y-intercept is 5. They pick another point, -1, 10, but it's okay if you just reflected the y-intercept across also. Graphing y equals x plus 1, the slope was 1 and the y-intercept was 1, so you went up 1, and then for your slope you counted up 1 over 1. Step 3, find the points where the two graphs intersect. They appear to be at 1, 2, and 4, 5. So we're going to substitute 1, 2 into the system. So we put 2 in for y and 1 in for x for the quadratic equation, and 2 in for y and 1 in for x in the linear equation, and we get 2 equals 2 and 2 equals 2, so we know that's one of our solutions. And then we're going to substitute 4, 5 into the system to check it, and we plug in 5 for y and 4 for x in the quadratic, and 5 for y and 4 for x in the linear, and we get 5 equals 5 and 5 equals 5, so we know that that is also a system solution. Remember, the substitution method is a good choice when either equation is solved for a variable, both equations are solved for the same variable, or a variable in either equation has a coefficient of 1 or -1. Solve the system by substitution. Y equals x squared minus x minus 5, and y equals -3x plus 3. So both equations are solved for y. We can substitute one expression for y into the other equation for y. We're going to substitute -3x plus 3 for y in the first equation. So we get -3x plus 3 equals x squared minus x. Then we're going to subtract -3x plus 3 from both sides, so we get 0 equals x squared plus 2x minus 8. And then we're going to factor the trinomial. We need two numbers that when multiplied give us -8, added give us +2. Those are 4 and -2, so we get x plus 4 times x minus 2. We're going to use the zero product property, and we get x plus 4 equals 0, or x minus 2 equals 0. Solve each equation, and we get -4, +2. So we're going to substitute -4 into the y equals -3x plus 3 to find the corresponding y value. So y equals -3 times -4 plus 3. We're plugging in -4 for the x and solve for the y, and we get 15. So one solution is -4, 15. And then we're going to substitute x equals 2 into y equals -3 times x plus 3 to find the corresponding y value for the 2x value. And we get -3 times 2 plus 3, which is -3. So the second solution is 2, -3. So the solutions are -4, 15, and 2, -3. Solve the system by substitution. Check your answer. Y equals 3x squared minus 3x plus 1. Y equals negative 3x plus 4. This one's for you to try, and then you can check back for your answer. So both equations are solved for y. We're going to substitute one expression for y into the other equation for y. So we're going to substitute negative 3x plus 4 for y in the first equation, and we get negative 3x plus 4 equals 3x squared minus 3x plus 1. So we're going to subtract negative 3x plus 4 from both sides, and we're going to get 0 equals 3x squared. So we're going to factor out the greatest common factor, which is a 3, and we get 3 times x squared minus 1. We're going to factor the binomial into x plus 1 times x minus 1. And then we're going to use the zero product property, x plus 1 equals 0 or x minus 1 equals 0. We're going to solve each equation, and we get negative 1, positive 1. We're going to substitute x equals negative 1 into y equals negative 3 times x plus 4 to find the corresponding y value. So we get negative 3 times negative 1 plus 4, and that's positive 3 plus 4, which is 7. So one solution is negative 1, 7. And then we're going to substitute x equals 1 into y equals negative 3x plus 4 to find the corresponding y value, and we get negative 3 times 1 plus 4, negative 3 plus 4 is 1, and the second solution is 1, 1. So the solutions are negative 1, 7, and 1, 1. Remember, the elimination method is a good choice when both equations have the same variable term with the same or opposite coefficients, or when a variable term in one equation is a multiple of the corresponding variable term in the other equation. Solve each system by elimination. 3x minus y equals 1, y equals x squared plus 4x minus 7. So we're going to write this as terms. We're going to add to eliminate y. We get 3x minus y equals 1, and y equals x squared plus 4x minus 7. So when we add them together, y and negative y cancel, and we're left with 3x equals x squared plus 4x minus 6, because the 1 and the negative 7 combine to be negative 6. Then we're going to subtract 3x from both sides, and we get 0 equals x squared plus x minus 6. We're going to factor it out. We need two numbers that will multiply, give us negative 6, add, give us 1. That'd be positive 3, negative 2. So we get x plus 3 times x minus 2. And we use the zero product property. We're going to solve for both. And we get negative 3 or positive 2. We're going to write one of the original equations. Y equals x squared plus 4 times x minus 7. Y equals x squared plus 4 times x minus 7. We're going to plug in negative 3 and 2 and find their y values. So then we get negative 10 and 5. So the solutions are negative 3, negative 10, and 2, 5. Letter B, y equals 2x squared plus x minus 1, and x minus 2y equals 6. So we're going to write the system to align the y terms. When we do, we realize they're not exactly the same. They won't cancel out completely. So we're going to multiply the first equation by 2 so that it will be positive 2y and negative 2y when we cancel out. So we end up, we get 2 times y equals 2 times 2x squared plus x plus 1. And we're going to add to eliminate y. We have 2y equals 4x squared plus 2x plus 2. And x minus 2y equals 6. So we have positive 2y and negative. So now we have x equals 4x squared plus 2x plus 8. And we're going to subtract x from both sides, leaving us with 0 equals 4x squared plus x plus 8. So what we're going to do is we're going to solve using the quadratic formula. So we get x equals negative 1 times b plus or minus the square root of b squared minus 4 times ac divided by 2a. So that's x equals negative 1 times 1 plus or minus the square root of 1 squared minus 4 times 8 divided by 2 times 4. So that's x equals negative 1 plus or minus the square root of negative 127 divided by 8. Since the discriminant is negative, there are no real solutions. Solve each system by elimination. Check your answers. For A, we have 2x minus y equals 2 and y equals x squared minus 5. This one's for you to try on your own, and then you can check back for your answer. We're going to write the system to align the y terms and add to eliminate y. So we get 2x equals x squared minus 3. Then we're going to subtract 2x from both sides. And we get 0 equals x squared minus 2x minus 3. And now we're going to factor. We get x minus 3 times x plus 1. We were looking for two numbers that when multiply gave us negative 3, added give us negative 2. So that was negative 3 and 1. And then we're going to use the zero product property. And we're going to solve both equations. And we get 3 or negative 1. We're going to write one of the original equations down. So the x squared minus 5. And plug in our x values to solve for our y. So we get the ordered pairs of where they would touch on the graph. So we have y equals 4 and y equals negative 4, so the solutions are 3, 4, and negative 1, negative 4. For B, we have y equals x squared minus 2x minus 5 and 5x minus 2y equals 5. This is still elimination. This is for you to try on your own, and then you can check back for your answer. So we're going to write the system to align the y. And now we need to multiply the top equation by 2 so that the y terms are the same but with opposite signs, so they will eliminate when we add them together. So we get 2y equals 2x squared minus 4x minus 10 on top, and then we have 5x minus 2y equals 5 still on the bottom. Now we have a positive 2y and a negative 2y, so we can add to eliminate. And then we have 5x equals 2x squared minus 4x minus 5. We're going to subtract 5x from both sides, and we get 0 equals 2x squared minus 9x minus 5. We're going to factor the trinomial 2x plus 1 times x minus 5, so you could use Xbox or the chart, either way. And we're going to solve the equations, setting 2x plus 1 equal to 0 and x minus 5 equal to 0. And we get 5 and negative 1/2, or negative 0.5. Now we're going to write one of the original equations, so y equals x squared minus 2x minus 5. Plug in the x values and solve for the y's. And we get y equals negative 3.75 when we plug in negative 0.5. And we get y equals 10 when we plug in 5. So the solutions are negative 0.5, negative 3.75, and 5, 10. The increasing enrollment at Southridge High School can be modeled by the equation ET equals negative t squared plus 25t plus 600, where t represents the number of years after 2010. The increasing enrollment at Alta Vista High School can be modeled by the equation ET equals 24 times t plus 570. In what year will the enrollments at the two schools be equal? We're going to solve by substitution. We're going to substitute 24t plus 570 for ET in the first equation. So we get 24t plus 570 equals negative t squared plus 25t plus 600. We're going to subtract 24t plus 570 from both sides. And we get 0 equals negative t squared plus t. Now we're going to factor the trinomial. We pull out a negative 1, and then we are looking for two numbers that when multiplied give us negative 30 and added give us negative 1. So we get negative 6, positive 5. So we have negative 1 times t minus 6 times t plus 5. We're going to use the zero product property. T minus 6 equals 0 or t plus 5 equals 0. Solve both equations and we get 6 or negative 5. In 6 years, or in 2016, because it was 6 years after 2010, the enrollments at the two schools will be equal. Negative 5 doesn't make sense because they're not going to be in session for negative 5 years. Helpful hint, when t equals 0, the ball and elevator are at the same height because they're both at ground level. An elevator is rising at a constant rate of 8 feet per second. Its height in feet after t seconds is given by the h equals 8t. At the same instant, the elevator is at ground level. A ball is dropped from the height of 120 feet. The height in feet of the ball after t seconds is given by h equals negative 16t squared plus 120. Find the time it takes for the ball and the elevator to reach the same height. You're going to solve by substitution. This one's for you to try on your own, and then you can check back for your answer. So we're going to substitute 8t for h in the first equation. And we get 8t equals negative 16t squared plus 120. And we're going to subtract 8t from both sides. And we get 0 equals negative 16t squared minus 8t plus 120. We're going to solve by using the quadratic formula x equals negative 1 times b plus or minus the square root of b squared minus 4ac divided by 2a. So we get x equals negative 1 times negative 8, which is positive 8, plus or minus the square root of negative 8 squared minus 4 times negative 16 times 120 divided by 2 times negative 16. So we get x equals 8 plus or minus square root 7,744 divided by negative 32. So x equals 8 plus or minus 88 divided by negative 32. We have two different equations to solve: x plus 88 divided by negative 32 and x minus 88 divided by negative 32. So we get x equals negative 3 or x equals 2.5. We can disregard the negative 3 answer. It doesn't make sense in real life. So we know that it's going to take 2.5 seconds for the ball and the elevator to reach the same height.